We're living in an age of wonder. Just consider all the incredible things we can do today that would have been unthinkable just 10 years ago. We can send text messages around the world instantly, talk to our friends on video calls, summon a car with a smartphone app, and have it drive us around without a human driver. And thanks to CRISPR, we can edit the genes inside living cells with the precision of a word processor. But despite all this, there are some things that science still can't explain. So, what does science have to say about the things we don't understand? And is there anything quantum physics can do to help? This is our channel, and here we explore the big questions of the universe. In this episode, we're going to look at how quantum physics helps us make sense of the universe. First, let's clarify what quantum physics actually is. Quantum physics, or quantum mechanics, is the study of how matter behaves at the atomic and subatomic level. For example, the behavior of electrons. But why do we need a whole new field of physics to understand these tiny particles? Can't we just use good old classical physics? Well, yes, for some things, classical physics works just fine. But for others, like understanding the behavior of atoms, we need a whole new set of tools. These tools come from quantum mechanics, which says that at the atomic and subatomic level, things work very differently than they do on the scale we experience in daily life. For one thing, things aren't really in two places at once. That's a common misconception about quantum mechanics. What quantum mechanics actually says is that things are in a state of potentiality until they are observed. When a quantum object, like an electron, is not observed, its location isn't actually anywhere. It's in a superposition of locations. Superposition is a fancy way of saying that the electron could be in multiple places at once. But when we measure where the electron is, say by shining light on it, the electron suddenly seems to be in only one place. The act of observation seems to force the electron to choose one location or another. Here's another counterintuitive idea from quantum physics. Electrons and other quantum objects can also be in two states at once, like a coin spinning in the air before it lands on heads or tails. This is called a superposition of states. But again, as soon as we measure the electron, its spin seems to suddenly be in only one state. So quantum mechanics tells us that at the atomic and subatomic level, things can be in multiple states at once. But those states are random. We don't know which state a quantum object will be in until we measure it. Now, you might be thinking, so what? Tiny particles are weird. But what does that have to do with the macroscopic world that we experience? It turns out that everything in the universe is made of quantum objects like electrons, so everything in the universe is subject to the laws of quantum mechanics. And that means everything in the universe is in a constant state of flux. Nothing is certain except change. We can never know exactly where a quantum object will be or what state it will be in. There's always some amount of uncertainty. Does that mean then that science can't really explain the universe? Not at all. In fact, it's just the opposite. Because if we can't know exactly what's going to happen, it means we can't predict the future with certainty. But that doesn't mean we can't make predictions. Quantum physics gives us a mathematical framework for making predictions about the future. We can't know exactly what's going to happen, but we can know the odds. We can calculate the probability of a particular outcome by using the mathematics of quantum mechanics. Let's go back to our electron. We know that the electron has a certain probability of being in different locations. We can map those probabilities onto a graph and see that the electron is most likely to be found where there is the highest point on the curve. But there's still a small chance the electron could be found in less likely locations. As time goes on, the curve changes shape. The electron has a greater probability of being in some places and a lesser probability of being in others. The mathematics of quantum mechanics allows us to calculate those probabilities. That means that even though we can't predict the future with certainty, we can still make predictions about the future. And that's really what science is all about. Thanks for watching this episode of SCI Show. And thanks especially to our supporters who make it possible for us to bring these videos to everyone for free. If you'd like to support us, you can get started at our support page.